All right, how about now? Yeah, all right. So to calculate volume, you guys did volume equals length times width times height, right? And I got 128.291 roughly. Did y'all get that? All right, so in rounding for significant digits for the quiz today, how many do we have here? And here? And here. So when I round there, how many am I going to get? So what do I round to? 128. All right, so when I grade your quizzes later, or quiz labs later today, all right, if you had 2 places behind the decimal, 2 places behind the decimal, and 2 places behind the decimal, you got full credit in your data table. So when I'm grading your volume, I'm looking to see, did you round off to 3 significant digits? If you did, then you got full credit. Now, on your units, if you wrote centimeters, centimeters, and centimeters, you're good to go there. And what did you write for your unit here? Centimeters cubed. Okay? Now, from there, calculate the density. So density is equal to 50.52 divided by 128. So when I calculate that, 50.52 divided by 128, I get 0.394687 roughly. Okay? Now, from there, we need to round for significant digits. This one has how many significant digits? And this one has? So 4 and 3, the least number is what? So I only want 3, so I'm going to round off to these first 3 numbers, right? So this number is greater than 5, so I can either say 0.395, or I would have taken 0.394. I would take either answer there. Now, what unit do I put on my answer? Grams over centimeters cubed. Okay, so if you did that on the lab, then you got full credit. Any questions about that? Now, if you have 3 significant digits, you're good. If you rounded that to 2, if you left 4, then I'll take points off. All right, so in the bottom ones, these are like what you're going to have to do on the quiz today. So I've given you, what's that, 23.4 plus 45.67 plus 3.012. Did y'all get 78.082? All right, so 72.082. So we need to round that for significant digits. What's the rule for that first question? Least decimal places, because we're adding, right? So how many decimal places here? Here and here. So I only want how many there? So I'm dropping off these 2. Now that number is greater than 5, so I can round that to 72.1. Now, if you didn't round up and you left it at 72.0, I will take that. Either answer is acceptable. Everybody okay with that? Okay, number 2, we're multiplying, then we're going to divide. So 14.30 times 3.01 divided by 0.035. We got 1229.8. All right. Did y'all get that? Okay. So this time we're using what rule? Significant digits. So how many significant digits do I have here? 4 here and here. So 4, 3, and 2. How many do I want there? So how am I going to round that number to 2? Okay, so this time I only want these 2, right? But if I write 12, if you had $1,229, would you be happy if I rounded that to $12? No, so you need to stay in the same decimal places, so you're just going to put zeros there. Does that make sense? Okay, so the last one. Remember, scientific notation is the same. You're only counting these numbers to figure this out. So when you punch this in, that times 10 goes in as what on the calculator? What do you use? second and EE. Good. So 3.45 second EE 5 times 4.3 second EE negative 8.
So you don't have to put the 10 in?
No, you never put the 10 in. That second EE means the calculator is programmed with that 10. So when that E pops up, it's just asking you the exponent. All right, so I got 1.4835. And I will tell you now, the ones like this on the quiz tell you have to put it in scientific notation. So times 10 to the negative second. All right, so how many, or what, let me ask this, what rule are we using to round that number? Are we using significant digits or decimal places? Significant digits because we're multiplying. So we look here, and this one has how many? 3, and this one has how many? And what's the least number? So I want these two. So I can either say 1.5, because that should round up, times 10 to the negative second. Or if you're not very good at rounding and just dropped it off, 1.4 times 10 to the negative second. I would take either. Okay? If you were adding, you do the same thing. And you just look at your decimal places and then drop off based on the decimal places. But you only use the numbers. You don't use that times 10 stuff.
What were you supposed to get for the first one? Like the answer? Like whenever you put 3.45 times second E, you're not supposed to get anything. I got 3.45 and then it has exponent 5. Did I do that wrong?
I don't know what you mean.
How are you supposed to type it in? I guess I'm getting confused by that.
You would say 3.45 second EE. You get an E to come up on the calculator. You just tell it 5.
Okay.
That's it. And then you say times. And then 4.3 second EE. And you get another E. And negative 8. And equals.
Okay.
Now, if it's not in scientific notation, you can either move the decimal yourself. Or remember, you can go to mode. And then use your arrow key over to side and enter it. Clear it off the calculator. And usually if you don't hit anything else weird, you can just hit enter and it will go ahead and change it for you into scientific notation. But if it doesn't work right, just punch it in again and it'll come up in scientific notation.
Okay.
Okay? Anybody else? Question on anything that's on the board? Anything before we take the quiz? Oh, do you want to go to the bathroom? It's after the 10-minute time. Huh?
I'm good.
You sure? Okay. Oh, by the way, if you don't use your hall passes, by the way, they're bonus points at the end of the semester if you save them. I don't know if I told you that the first day. What's wrong with that one, Amaja? Dead batteries?
No.
You just don't like the way it looks?
You got like lost, yeah.
Okay, then that's fine. But if it's dead batteries, let me know and we'll change them. So nobody has a question. So we're all good. All right, you need a writing utensil and a calculator because you're just calculating today. Angela, you taking it or making it up? Say what? The view, you weren't here. This week, I'll be here a little bit today, not very long, because Saturday week is apparently next Monday. And I'll be here tomorrow about 4:15. And then Thursday I have a meeting, so I can't do Thursday. And next week, I have several days tomorrow. Okay. The thing was not that. He's my normal Henry Albert. It's not going to go to an S. He's not taking it. He wasn't here on Friday. And you just left on Friday too, so we're that up. And when you finish, just flip it upside down. Remember what I told you. There's no partial credit on this. So if you calculate it wrong because you punched in the calculator wrong, it's automatically wrong. So don't just punch it in once and assume you have the right answer. Double check yourself. It's real easy to screw it up because you did not double check yourself. Thank you, ma'am. What's wrong?
Oh, sorry.
How many of you guys are still working? Okay. Yep.
-1.
Yep. How many of you are working now? So I only got one? All right, Caroline, you tell me when you're done. And I'm just putting names into zip grade for the test. Okay. Pass them to the front, please. Thank you. All right, if you guys will find your notes. We need to do heat and temperature today and get started on physical and chemical properties. Because tomorrow I want to be able to finish that in a mini lab. So on Friday, we didn't have but about 5 minutes. And we started talking about temperature ever so briefly. And I know we wrote down the definition of temperature. Okay, I don't remember anything beyond that, but I know we wrote the definition. So what was the key part of the definition and temperature that we wrote down? All right. So the key part to the definition for temperature is it's a measure of the average kinetic energy of the particles. Okay? Now, we're going to compare that with the definition of heat in a few minutes. Now, from there, I'm thinking we talked about how we measured it in the units. Do we do that? Okay. So, to measure temperature, we said we would use a thermometer, and I'm certain I would have made a big deal about how to spell it. Because if I ask you that, it drives me crazy when people spell thermometer and all they get right is TH. All right, it's a thermometer for those of you who have terrible spelling. And I'll be the first to admit my spelling is terrible. Sometimes you'll see me pause at the board and stare at a word because in my head I'm running through how to spell it so that I don't look like an idiot. Or I might even turn around and look at you and go, how do you spell this word, so that I get it right. So don't feel bad if you can't spell it. But thermometer is thermo and meter. Now, the units, and I'm thinking now that I'm remembering, we even talked about the formulas that we're going to use for our 3 units. So we said we were going to have Fahrenheit, which is the English unit that we use here in the United States. Lift the N out. All right. Celsius, which is used in every country except the United States. And Kelvin, which is used by scientists. Now, we need to be able to change between those 3 units pretty easily. And I know we didn't do that on Friday. So the formula that we use to go between Celsius and Kelvin, I told you is on your blue formula sheet. That one is K equals C plus 273. And this one is a pretty easy formula. We will use this one a lot throughout the year. You will see it on your exam, and it's given to you on your reference sheet. However, because you're in honors chemistry, everybody needs to be able to change Fahrenheit to Celsius. Now, some of you have phones that have apps on it and will do it for you, and that's fabulous. You're in a chemistry class. You need to be able to do it without punching it in your cell phone. C equals 5/9. F minus 32 is the formula I told you to write on your blue sheet. Now, Angel's the only one who is not here, so he needs to add it to his blue sheet. Now, if you are like Angel and you didn't write it down, you need to add it. So if you look on your blue chart that I gave you, Angel, on I think it's page 3, there's a whole bunch of formulas. Just add it to the bottom of your blue sheet. Because it's not one the state's going to ask you to know, you can use it on my test. Now, typically at this point, I sometimes assume that people know how to use these formulas. It's usually my bad. I should never assume that. So rather than me making that colossal mistake, let's make sure everybody can use these formulas. So if I give you something like 275 Kelvin, and I ask you to change that to degrees Celsius, and first of all, K is the only one that does not have a degree symbol on it, so I will never write a degree on the K. There will only be degrees on C and F, in case you're curious about why I don't do that. Kelvin does not have a degree on it. Which formula would I pick to make that conversion? Good. I imagine. So we're going to pick the K equals C plus 273. I'm going to put the 275 in for which letter? Okay. And then you've got a math equation that you probably learned how to solve in, best guess, 5th or 6th grade. So how do we solve? Subtract by 273 on both sides. And degrees Celsius would equal to what? 2. Now, a lot of times people leave this answer for me this way. Is that okay? The degree Celsius on the right-hand side is the variable. I need to write, or in this case, just C really is the variable. I need to write degrees Celsius on my 2 so that my 2 has a unit on it. Okay? Don't leave your unit off your number. The number has to have a unit on it. Now, that's the easy one that we will do all semester long, and everyone's always okay with that one. It's the other one that sometimes causes issues, and the reason is it has a what in it? It has a fraction. Okay? So, suppose that we're going overseas, and the temperature outside is going to be 24 degrees Celsius. Do we need jeans and a coat, or do we need shorts? Y'all know? I only know because I've converted enough times. All right? But typically, if I traveled overseas, I'd have absolutely no idea how to dress if I saw degrees Celsius. All right? That's not a temperature that I live with. All right? If you grew up overseas or you've been in a foreign country, you would probably know what that would mean. But most of us would have no idea because we've grown up here in the States. So, C equals 5/9, F minus 32. So, putting in our 24 for what letter? Now, like I've told you guys before, I wrote that really large. All right, you're going to solve. You may do it any way you like. If you have great math skills, do it whichever way your math teacher taught you. Okay? I'm never going to tell you you can't. If you have weaker math skills, I only solve it one way. Okay? Simply because in high school, I sucked at fractions. So, how do I solve it? I cross multiply. I'm getting rid of that fraction. All right? So, 9 times 24 is 216. 216. 1 times 5 is 5. F minus 32. Now, I've gotten rid of my fraction. I'm home free because I got rid of the fraction. Now, you have options from this point. You can distribute. You can divide by the 5. You choose. It doesn't matter to me which way you do it. I'm allergic to big numbers. I tend to divide by the 5. But if you saw it as distribute the 5 through the parentheses, distribute the 5 through the parentheses. Which way do y'all see it? Alex, when you saw it, what'd you do? Then distribute, okay? Alex saw it as 5F minus, I think that's 160. Yeah, 160. Okay, so add 160 to both sides. I really need to take this thing out of scientific mode so I don't have to keep changing these things in my head. 216 plus 160. So add 160 to both sides. So 5F equals, what do I get? 376. All right, and from there, what do I have to do? Divide both sides by 5. Anybody already done it for me? What'd I get? 75.2. Am I going to need jeans and a coat? No. Probably not. Shorts will probably do it for me, or at least jeans without a coat. Okay? So, degrees, and an F will be my unit. Okay? Questions about how to solve? Everybody okay with those two formulas? Yes? Remember doing all that in math class? All right? They're basically what I call plug and chug. All right? I'll give you some more of that to practice for homework or in a little while, but I want to get to the other equation that you're going to see. All right, everybody got it? All right, let's talk about what heat is. Heat is a concept that we will revisit later in the semester, particularly when we do phase changes and you have to learn how to graph and calculate with heat of fusion and heat of vaporization. They're really, really boring topics that I hate to teach later in the semester because they're dry as this floor. But unfortunately, they're part of the curriculum and I can't escape them. So in December, when we're all dying to leave for Christmas break and we are bored, senseless, and we are just chomping at the bit to get out of here, and we're like, oh my God, there's 3 more days and it'll be Christmas, and I'm going to have to teach the most god-awful part of the curriculum there has ever been invented. Please bear with me. So, heat. Not that this isn't any more exciting, but it's even worse. Heat is the sum total of all the particles of all the, I left a word out that I need, all the kinetic energy of the particles. Okay, it's the sum total of all the kinetic energy of the particles in a sample of matter. Now, what makes this definition different from temperature? What? That's right. Okay, so in the definition of heat, I said sum total of kinetic energy. Okay? In temperature, I use the word average. Do y'all have a job? We all have jobs, right? Do y'all want to be paid on your sum total hours or your average hours? Sum total, okay? For example, I come to work and I work roughly 8.5 hours a day. I'm supposed to be here 7, but I work 8.5 hours a day, sometimes longer. Okay? I work 22 days a month according to my paycheck. Do I want to be paid on my average hours or my total hours? Total. I get paid 22 days out of the month. If I only worked and got paid on my average hours, I'd be paid on how many hours? 8.5. That would suck. My paycheck's bad enough. Much less getting paid only on 8.5 hours total. Can you imagine how small my check would be if I only got paid on 8.5 hours? All right, divide how many hours a month you work. Or week, let's say a week. 8.5. How many do you work a week? Huh? You ain't even going to tell me how many you work? That small? 5 hours a week. Okay, you know what we're talking about. Anybody else got a job? How many do you work? Like 15. Okay? How many a day when you go? Like 5. So if you got paid 15 hours a week and the average is 5, it would make a difference if you only got paid 5 hours total, wouldn't it? That would be terrible. So if we want to talk about examples of heat versus temperature, okay? The only thing I can draw, don't get excited. Because this next one I'm going to butcher. Any ideas?
Nothing.
Okay, I didn't do too bad. Okay. Now, which one has a higher temperature and which one has more heat? And then we're going to talk about why.
It's
The teacup has what? Okay. Teacup is going to have a higher temperature. Which one has more heat? The bathtub. Okay. Now, we need to talk about why. Why would the bathtub have more heat? What? Okay, when you say sum total, not everybody in here knows what you mean by sum total. So can you give me something that will explain to them what you mean by sum total? It would be more obvious to everybody.
More water.
More water, okay. So when we talk about heat, okay, heat equals size or mass, okay? More mass. Okay, that clue did not do what I wanted. Equals more heat. Now, it's going to sound a little offensive, but you know, I'm a big girl, so I can say this. Skinny people can't. I am a large child. All right, I'm very fluffy. So I have more heat. All right. People pick on Caroline, but she's a little skinny over here. Okay. So in this very, very chilly room, I have more fat on my body. I am not going to get cold in this room because I have all this insulation. So Caroline has to wear a long sleeve shirt. Elijah has to wear a jacket in here. They don't have all this insulation. So their particles are not as massive. They don't have all this heat. Okay? So us plus size people don't get as chilly. All right? Same. Now, more particles you have, more heat you have. So when you look at the bathtub, all right, the bathtub has a lot more particles, it has a lot more heat. The teacup, however, has much less particles, it has less heat. And I was not saying that to be insulting, just to make a point. Now, when we talk about temperature, temperature equals motion. Okay? So, more motion equals higher temperature. So, how many of y'all play sports? Okay. Right now, what are y'all doing? Sit and sit. So as you sit still, what happens to the particles in your body? They go faster or they slow down? Slow down. So you get still, you get the sensation that you feel how? Cold or cool. So you guys wear long sleeve shirts, you wear hoodies, you wear jackets because you know as you sit still, you're going to feel cold or cool. Me, I'm up teaching. I don't need to wear a jacket. I do have one there in case I get cool second period, but generally I'm fluffy, I don't get cool. Now, you go to after school, you go to practice, whatever sport it is that you happen to play, run, whatever, you start to move around, what happens to the particles in your body? They go faster. As the particles go faster in your body, how do you start to feel? You start to feel hot or warm, okay? That's temperature. You understand the difference? All right, the more you move, the warmer you feel. Now, if I was to ask you something like this, which has more heat, let's say, swimming pool in August, a cup of coffee, a frozen lake, a can of soda. Would you be okay with answering that? What's the answer?
B.
All right, I got A, I got B. I had very few votes coming in. Sure, room temperature. Can of soda. It's not even in the refrigerator. Room temperature. I got A over there.
Coffee.
I got coffee.
Lake.
All right, I got a Brave Soul at the back of the lake. Oh, go and C here. I got 2 C. I got 3 lakes. So I got 3 lakes. I'm going to take it a minute. Wait and see if anybody else is going to chime in. I got a couple D's, I got a B, and I got several A's. Okay? Why is it C?
Because it's big.
It's massive. When you compare it to A, B, and D, it's massive. So it doesn't matter that it's frozen, it's gigantic when you compare it to the others. So when you add up all the particles, it has more heat than the others. That's why I asked you.
Frozen.
Okay? So it doesn't matter that it's frozen. Take that out. Okay? It's huge when you compare it to the other 3 objects. Okay? This, we can put I don't know how many swimming pools inside of a lake. Okay? So even though we're talking August, it's still not going to outsize that lake. Okay? All right. Now, how do we measure heat? Okay? The equipment that we use, and you're going to do this lab later this semester, we're going to use a calorimeter. All right. Now, we don't have any calorimeters here, so we can't use the fancy equipment. However, I'm pretty ingenious, or at least I tell people I am. So we're going to use a styrofoam cup and substitute out a calorimeter for a styrofoam cup, and we'll be able to do the same experiment with, a couple bucks from Food Line. The units for heat are a calorie, which are the English units. So those of you who are familiar with calculating your calories, that's how much you burn. Those are the English units. We're scientists, so we're going to use, and it's pronounced joule. Joule is the SI unit, and that's what we're going to use. However, calories are English. So if you see calories, that's just the English unit for heat. All right? Now, the formula that we're going to use is given on your reference table, so you don't have to memorize it. It's Q equals mCp delta T. Q is heat lost or gained. It can go either way. It can be lost or it can be gained. M, everybody knows M. What's M stand for? Mass. CP means specific heat. And delta T is actually a math term. A lot of people know it, but some people don't. Does anybody know what the delta stands for a math class? Mm-mm. Some people have seen it, some people haven't, so it's okay. It means change in. And because there's a T, it means change in temperature. Now, the units that go with it. This is the only formula that we will do all year that temperature can be in degrees Celsius or Kelvin. Every other formula we will do this semester, and you'll hear me say this a lot later in the semester when we use temperature, the formula has to be in Kelvin. The formula has to be in Kelvin. This is the only one that can be in either unit, so it doesn't matter. We will largely leave it in Celsius because it doesn't matter, but it can be in either. Grams has to be mass. Now, let me point this out. When you're reading these word problems, if it just says the word heat, it's talking about Q, and it will be in joules. If it does not say specific heat together, it's Q, okay? Did everybody hear me say that? If it doesn't say specific heat together, it just uses the word heat, the four-letter word heat, it's talking about Q, okay? In order to be CP, it has to say specific heat, both words together, to be this CP, okay? If it just says how much heat, something about the word heat, singular the word heat, it's talking about Q. Specific heat is CP, and it has to use both words together. That unit is joules over grams degrees Celsius. It's also on the reference table. So if they don't give you specific heat, it's not given in the question anywhere, and you need the specific heat, it's on your reference table. Some of you, when we did the first quiz, and you were looking up the density for, I can't remember if I gave you lead or gold, whatever was in that first quiz, the density question, some of you actually used the specific heat for that element because you looked it up in the wrong column. Okay? Those are the parts of the equation.
What is that? REF?
What? REF, reference table. I am pretty good. Stands for reference.
And that's J over G. Right?
J over G degrees Celsius. Now, the nice part about that unit, find your blue reference tables for a second. Pull them out. We're going to use them today. Let's say, for just a second, that you forgot that unit. You're like, dang, I got to put it on my quiz and I don't know the unit for specific heat. Turn to page 1. Find the column that says specific heat on page 1. What's right beside the word specific heat in bold? J over G C. There's your unit if you forgot. Okay? So if you forget the unit for specific heat, you can look it up. There is also the column for specific heat if you need it. Okay, which you will. So leave it out on your desk for a second. All right, everybody have what they need, because I'm going to make this go away and pull up my word problem so you don't have to look at my bad handwriting. At least I think I am. There we go. All right, I'll give you a minute to write that down. Yep. Yeah. All right, we got it? Yes? No? No. No. Come on, I already added 2 new people.
Are you supposed to be solving it?
No, just write it down. I'm going to solve it. Usually I do at least 2 with you before I expect you to be able to do it yourself. Some of y'all are more willing to try on your own, but usually I do at least 2. All right, so what am I asking you to find? If I just say, what is the heat? I'm asking you to find what? Q, okay? So my formula is Q equals MCP delta T, and we're looking for Q. That means you know we have to have the other 3 variables, right? M, everybody can find every year. So what's M? Okay, so what is it out of the equation? 15.0. That's what I mean. Everybody can find grams, right? So we need CP and we need delta T. Now, specific heat is not given to us in this question. See how we have Celsius and Celsius here? We have how many? That is something we're going to have to calculate. We have a change in temperature given to us. Change in temperature means to do what? Subtract. We need a difference, right? So we're going to take the 2 numbers and subtract them. Now, sometimes you won't have to subtract because they'll just tell you the temperature increased something or decreased something. But a lot of times you're going to have to subtract them. So 67.5 minus 45.1 is 22.4. Now, from there, we've used all the numbers they gave us, right? We don't have any other numbers. So this is why I said you needed your blue reference table. The state is not going to tell you in the parentheses, use your chart. You're going to have to know this on exam day. So you need to find heat. You've used every number you have. So now you're going to look on your reference table. You need the specific heat of what element? Iron. So now find iron on the first page. Is it 0.449? Yeah. So 0.449 is your specific heat, and then you plug it in. Now, because your units are grams here, joules over grams, degrees Celsius there, and degrees Celsius there, what is going to happen to our grams? They're going to cancel out. And what's going to happen to our degrees Celsius? They're going to cancel out. And so Q is going to wind up being a joules. So when we calculate, we have 15.0 times 0.449 times 22.4, 150.864. Now, the final step is rounding to the correct significant digits, right? So how many did I have in 15.0? 3. And 45.1? 3. And then 67.5. So we need 3 in our answer. So what am I going to round to? 151 joules is fine. What numbers did you look at to figure out numbers? You always look at the given data. So here, here, and here are your only numbers you look at. You don't need to look at your blue reference table. No. Only the given data in the question. All right. So we had 3, 3, and 3. We multiplied, so we used the least significant digits. So these 3 are what I want. Now, if you wanted, you could have said 150, and as long as you wrote your decimal there, you would have been fine also. I would have also taken that answer. Because, you know, I had a decimal there. So you could have just written the decimal. Now, would I have taken 150 joules like this? Would that be okay? No, because that is what kind of decimal? Understood. Understood, and that's not significant, so I won't take that one. I mean, I'd only write -1. If you had given me this, I would have written -1 SD for significant digits, and I'd have taken a point off your answer. Okay? It won't be wrong. You just lose a point for significant digits, and you don't want to lose your points. Okay? Questions? All right, can we try another one? All right, what about this one? Do you want to write it or no? You tell me. Okay, I wouldn't write more than 2 examples. I would think 2 would be plenty. All right, you ready? So, what are we solving for this time? Specific heat. So what variable is specific heat? Okay. So we're looking for that variable. So that means we got to have the other three given to us because CP is the one we find on the reference table. So that means everything else is given. So what is something we know? Okay, what's the heat? Okay, so 565.4 goes there. All right, something else we know. Anybody other than Christopher? He already gave an answer. Mass is what? Okay, 525.2. All right, I need one more. Okay, so how'd you get that, Angel? All right, so Angel took these two things and he said he subtracted. Okay, so when you subtracted that, what'd you get? 48.5. So we're putting 48.5 there. All right, everybody okay with why and where we got those numbers? Yes, no, anybody not? Speak now. Don't be shy. I promise I don't bite. I don't even yell real loud. I only yell at my own kids. And I do that regularly. All right, so 525.2 times 48.5. So you can do this any way you want. I tend to combine like terms. Okay, so I combine like terms. Now I'm going to do what? I'm going to divide on both sides.
Did you just multiply the numbers together?
I hope. Did I multiply them wrong?
No, I just didn't.
Yes, I multiplied them. That's what I did when I combined like terms. Make sure I multiply them right. Yeah, I got the same thing again. 565.4 divide 25472.2. 0.022. .196. That should be enough to be able to do significant digits. All right. So again, we need to do significant digits, and then I'll slap a unit on there. So when I look at this, how many significant digits do I have in my question? What am I going to need for an answer?
3 digits.
All right, I hear 3 over there. Y'all check and see if she's right. Okay. The least number I have is 3. That's a 4. That's a 4. That's a 4. That's a 3. So I only want 3. So does this number count? No. So I need these 3 right here. So 0.0221, or if you round it up, 0.0222. Either answer is fine. Now we need a unit. Are grams, joules, and C going to cancel each other out? I got a gram, a J, and a C going to cancel each other out. Are any of those going to cancel?
No.
Now, if you don't remember where they go or how to write them, where did I tell you could look?
The sheet.
On the sheet. Okay? So, copy it down if you don't remember how they go. And there's your unit. Questions? Think you could try one on your own? Denacia's looking at me like, Question? Yes, no? You sure? They pay me to answer questions. I know. It's all rather shocking that that's what I draw a paycheck to do. But. All right. How about that one? Y'all try that one. You don't have to write it down. You already got 2 samples. ready? Say yes or no. About now. We talk about it? All right. What are we solving for? Okay. So Q equals MCP delta T. We're looking for M. So what's Q and today? What'd you put? Okay. And what'd you put for delta T? Yanit. 43.5. Okay. And what do we put for CP Angel? That Angel. 0.35? 385. Everybody agree with what they have? Other than my X is too close. Let me move that. Everybody agree with their placement? Okay. Because the question says copper right here. So you'd have to look up the specific heat of copper.
So will we like 99% of the time be given that number?
Will what?
Will we be given that number usually? Like, do we ever have to solve for it, figure it out?
Yes, quite possibly. Like on the homework tonight, there's one that I said find the specific heat for. You need to solve for it because it's just flat wrong. I think it's number 2 because I made up the numbers. This was before they gave you that stupid reference table. Yeah. Are you raising that pencil? More than one missing? No. No, there will never be more than one missing because you wouldn't be able to solve. Okay, so 43.5 times 0.385 is 16.7. Divide by 16.7. So 65.8. Divide 16.7. I got 3.94. Did y'all get that? Close enough? Yeah. I rounded off. Yes.
I divided it by
No. No. Now, when Jada asked, she divided it by something I didn't. If your answer is in this ballpark, your answer is fine. Okay? I rounded here because I was tired of writing all those numbers down. You wrote down more numbers than I did. If your answer is in that ballpark, that's fine. How many significant digits should you have? Hold on. I didn't look. I only looked up there. It should have 2. 3.9. I thought I had another decimal place there because it was covered by the thing. 3.9 grams. I needed to move my little box. All right. 3.9. 42 only has 2. So you should have 3.9. So when I'm looking at your answer, if you have 2 significant digits, let's say you have 3.8, I have 3.9, I'm not going to mark that wrong. You just rounded differently than I did based on how you rounded this number, and that's fine, okay? I'm never going to take off for that. Everybody okay with that?
Where did the units cancel out?
Because this was a joule. This was a joule over gram degree Celsius. Let me fix that. And this was a degree Celsius. So the joules left, the degrees Celsius left. And so we were left with the gram. Anybody else? Question? You okay with that? All right, I'm going to give you more practice with that for homework tonight. Where am I at time-wise? I have 10 minutes. Cool. All right, let's talk a little bit about some new stuff. Now, we've been talking about physical and chemical properties and physical and chemical change we'll get to tomorrow. But some of the stuff we've been learning about are physical properties. So I tie in physical and chemical properties and physical and chemical change for this topic just because it's not as boring and we can link it to the beginning of the semester. Now, before we do that, though, a couple words that everybody should know in a chemistry class that some of you do know and some of you probably don't know, depending on the teacher you had in middle school. All right? Now, tell me what matter is. All right, it's got to take up space. Needs one more part. Has to have mass. Okay. Taking up space and having mass, taking up space and having volume are the same thing. So, matter is anything that has mass and takes up space. Now, some teachers don't teach it that way. They teach it as has volume. Both definitions mean the exact same thing. So if your teacher taught it takes up space, cool. If your teacher taught it has volume, cool. They mean the exact same thing. Just depends on which teacher you had as to which definition they taught. They're identical, okay? But you have to have a mass, and you have to take up space or have a volume. If you don't have both parts, you're not math. So, let's see how well you understand that from your earlier experiences. So, if I ask you for 3 examples of things that have mass. 3 examples of matter. Give me any 3 things in this room that have matter. Desk? Sure. Desk, people, and calculator. All right. Now, this is usually, if we have issues with the definition, where we hit a glitch. Okay? Now I want you to give me something that is not matter. Okay? Something that does not meet that definition. That's usually where we hit the glitch. Okay? You did exactly what I wanted, Diamond. Thank you. I know somebody's going to be brave and give me that, and I don't want you to feel bad by yelling it out. Okay? But that's usually where we hit the glitch. Everybody yells out usually air, and the other one I usually get is water. Okay? So don't feel bad. Okay? You are one of, I've done this 27 years, and every semester people yell that out. So you are in a great group of company that you yelled it out. So don't feel even remotely bad. All right? Air fits over here. All right? How many of you walked today to school? Not a soul in this room. So everybody else came in some form of transportation. Did y'all come on block wheels? They rolled on a square, another square. Nope, I didn't either. I came on 4 tires. What was in those tires?
Air.
Were they inflated? With what?
Air.
So they had space and took up a volume. And if we put it on scale, guess what? It has mass. All right, air is matter. How many of y'all have had birthday parties? Some kind of gas was in those balloons, weren't they? Some were helium. Some of us, real cheap, can't get our balloons to go up in the air. They lay on the floor. What are we putting in the balloons?
Carbon dioxide. Never mind.
All right. Those biology teachers over there rolling around on the floor right now. All right. So before y'all yell out stuff, all the gases fit over there on the matter side. All right. Water fits over here on the matter side. That water that's in my bottle over there has a mass, and it takes up space. So, now, can you give me something that does not matter? What? Take up space. Got a mass. Teeny tiny, but it takes up space and has a mass.
No.
No. What's the first thing I did when I finally got my key free from everything dangling around my neck? Because if I work really hard, I can see how fast I can do that, Dad? I'm working on my physical therapy for 4 days to be able to do that. Y'all can see my fist. You want to see my fist? That's all I got. Okay? But it's going to be better in a few weeks. All right, so it's the first thing I did when I unlocked my door today. Very first thing, I unlocked the door and opened it. What's the first thing I did?
Turn the lights.
All right, light does not matter. Has no mass and it does not take up space. What? Sound. There you go, Diamond. All right, sound does not matter. Light, sound. Just talked about one of them. Fluffy Girl has more of it than y'all. Temperature's good. What's the opposite? Heat. Light, sound, heat. Starts with an E. Energy. Okay? Those things do not matter. They don't have a mass. They don't take up space. All right. I want to do, let's see, we got 4 minutes. What are the odds that y'all can tell me the difference between these two words and we can pass out homework? I don't think they are either, but let's see what we can do. All right. Mass, weight. Y'all should have talked about these and know these too. That might be a little premature. I'm thinking 4th and 5th. Maybe early middle school at the latest. Not bad. Say what? Okay, which one has the effect of gravity?
Weight.
All right. Okay, so the measure of the amount of gravity on an object, typically we talk about Earth's gravity, but it does not have to be Earth's gravity. It could be the moon or another celestial object. All right. So what did we say mass was? Somebody who yelled it out a second ago? What did y'all say? Huh? Somebody told me something about mass a second ago, but I forgot what they said. What did you say? Me either. Okay. It's the amount of matter in an object. Now, for homework tonight, I'm going to give you a half sheet of paper, and it's on heat and temperature calculations. However, I want you to figure out for me the major difference between mass and weight. Do not tell me the definition when you come back tomorrow. The major difference is not telling me the definition. Okay? I can do this. I'm going to drop half these papers on the floor. Some of y'all are going to be like, Miss Wall, I got to go to the craft go. Yes. Yes. Somebody steal and mess up. Where do you want to set? Where do you want to set? I just don't want anybody to mess it up. I'm coming, I'm trying. These fingers don't work. How many I got there? If I got enough. Oh, it's there. I got an extra? Whew. I'm stressful. Somebody else got to hand these out tomorrow. If you still got a calculator, put it in my tub. Today's your word you decide to put it. Okay. Hey, my concern would be somebody would mess with your stuff. My third period's pretty good. Fourth period, not so much. All right.